Hello, everybody. Here we go. 2018 question BC Calculus number 2. All right, good luck for this one, ladies and gentlemen. This one, every now and then I get to a problem where it even stresses me out a little bit. This is a very stressful problem. You're going to have to fight through problems like this. They will have something challenging on the AP test. They will test your knowledge to really problem solve. That's what this one's all about. Remember, you don't have to be perfect. You don't have to get 100%, but your mission is to stay calm, relax, and try to get every single point that you can. So away we go, the dreaded plankton problem. Researchers on a boat are investigating plankton cells at sea. At a depth of H meters, the density of plankton cells in millions of cells per cubic meter is modeled by this function. That's only relevant when the H, and what is the H here? The H is the height, the depth that you're in the water in meters. That's only relevant from 0 to 30. Beyond 30, you got to switch functions to F, and F's not really given to you. Okay, so now, well, the first part, pretty easy. Just find the derivative of P. This is P, find the derivative. This one here, I would just plug into my calculator. You can try to use product rule with chain rule if you want to. It's not exceptionally difficult, but it's so much easier in the calculator. And we just care about the answer here. So the answer is 1 point for negative 1.179. Then interpret the meaning. Well, once again, as you're writing these kind of little notes to yourself, P of H is in millions of cells per cubic meter. So here I put cells here, but I really should have millions of cells per cubic meter. And then remember, that's P, so that's your y-axis. And H, not like normally it is a T or X, H is your x-axis. So that's H. And what is H units again? H units is in meters, so I put a little green here for my units. So when I'm figuring this out, they want a derivative. Derivative is division, so it's cells per cubic meter per every meter. That is extremely important. So you have to have those correct units. Millions of cells per cubic meter per meter. You could obviously divide these, put this over M if you want to, and just kind of write it like all that. If you really wanted to simplify this, you can cells per square meter, but that just doesn't make it much sense here. It really makes more sense to me that the density of plankton, millions of cells per cubic meter, how densely they're packed in there, is changing by every meter that I go down underneath the water. So that's kind of your one. Now, don't forget your other point. Don't forget, you have to not just talk about P prime of H, but you must talk about P prime of 25. So you really need to have this 25 in your explanation also, or else it's just a general answer, not a specific P prime of 25. Part B. Now it starts to get a little bit more hairy here. Consider a vertical column of water in the sea with a horizontal cross-section of constant area 3 meters. To the nearest million, how many plankton cells are there in the column of water? So this, you have to remember, is kind of like a rate. In general, how do you go back and get total plankton cells? You would integrate that rate. It's a little trickier here because there's this extra 3. So wrapping my head around this, I kind of drew a little picture of a vertical column of water, and you're basically just slicing this up, and you're going, each one of these little slices is going to be your integration. And as you keep slicing this little, I'm doing circular cross sections here, you're going to be summing that up with an integral. So you're going from 0 to 30 of all these slices, but these slices have an area of 3. So that's each one of these. But you also have, you want to get the 3 is just the area. You want to get somehow total plankton cells. So you have to get that P of H in there because that's relevant from 0 to 30. So if you think about this, remember to try, this is what I would write out of my paper as I'm going through this. I know I need millions of plankton cells. So how do I get that? So if you mess with the units, you can kind of say to yourself, if you understand how to do integration, which is really what the AP Calculus is testing you on, do you have a deep understanding of integration? 3 is square meters. Okay, that makes sense. And this P of H is in millions of cells per cubic meter. If I multiply these, I get cells per meter. So cells per meter. But if I integrate that, the DH, the change in this, which you want infinitely small, is also in the units of a meter. Go back and look at part A, my little graph there. So if I do an integral, then I'm multiplying. So you're multiplying this to get it to cells per meter. And then when you integrate, you always multiply your units on the y-axis times your units on the x, but in this case, it's the h-axis in meters, and that just gives you total cells. So your integrand, that's important. You need to have the 3 integrated in there and know that you needed the P of H. It just says integrand, so you don't have to have the 0 to 30, although I think that's the easiest part of the problem. And then, of course, just typing that in, we get this answer. No, you don't have to have all these decimal places. They show more than 3, but it does say to the nearest million. So really, if you don't cut that off as 1675, they just really want to illustrate that it's a 4 there, you're not going to get that answer point. And then comes C. Same stuff going on, but then there's a lot of extra stuff here. Now, when you get to something that really stresses you out, like this problem kind of did to me when I first read through it, read through it once, read through it twice. The other piece of advice I have for you is kind of draw pictures and power through. You never know how many partial points you're going to get. So there's a function of u such that this u is larger than the f. So the f is under the u. And then this is always true for h bigger than 30. Remember, f of h is bigger than 30. Below 30, you have to use this P of h piece. And they also know that the integral from 30 to infinity of this u is 105. The column of water in part B is k meters deep. So it was 30 in part B, but now we're going farther than 30. We're going like this k. So we've been diving deeper down underneath the water past 30. You don't really know how far because it's greater than 30, but that's all you know. Write an expression involving one or more integrals that gives a number of plankton cells in the entire column. So the number of plankton cells in the entire column, that's kind of what we did last time in part B, except we're going farther. So just breaking this up and thinking about it, you need to do the exact same thing you did in part B, but then you need to go farther past 30. And remember, the P is in purple highlighter here. That's this little strip. But once you get past that, you jump to a new function, which I highlighted in this blue, and that's your F function. So now you just have to do this. This right here is actually a simple problem. If you kind of understood B a little bit with that 3, and even if you didn't, if you forgot the 3 or something in part B, they ding you there, but they wouldn't ding you twice here. But the integral expression, that is kind of like the easy gimme point. Now, if you can't get the rest of this, number 1, 9 points, you can still get a 7 out of 9, which is great. And in my opinion, if you get like a 4 or 5 on this question, that's still pretty impressive. But now, you need to do this other stuff. Explain why the number of plankton cells is less than or equal to 2,000 million. All right, so now let's kind of unpack this. So we need to figure out that this total is less than 2,000 million. You do know that this, obviously, we have to use it. It's, once you get past 30, there's this u, and the u is bigger than the f, or the f is under the u. So you're first of all going to know this answer right here. This is from part B, that's the 1675.415. And then you're going to be adding what this is. Now, you don't know where this k ends, so that's kind of an issue. You don't know where the k ends, but what's the largest k could be? You know, could k be like 40, 50, 100? Well, the largest it can be is if k went all the way out to infinity. So if you think of this original function here, and pulling the 3 out is probably a good idea to really understand all this, because a constant just doesn't affect everything, it just moves everything up by a factor of 3. If you go from 0 to k of f, that's going to be under, 30 to k. And if you go, that's going to be under 30 to k of 8 of u, just because of this inequality they gave you. And this, of course, has to be under infinity because I mean, k can't really be infinity because that's not a number, but it's going to definitely be under infinity. It could be 1,000,000. You just don't know what it is. But you do know what this answer is. This answer, the absolute maximum piece of all this, is going to be 105 because they gave that to you right here. So if the absolute maximum is going to be 105, 105 times 3 gives you a total maximum of 315. You know that the k could be under the infinity, so that has to be a little bit less, because that's the biggest it can be. And u is even under, f is even under u, so then that has to be a little bit smaller. So this right here is the absolute maximum value that can be. Notice with the less than's or equal to's. Now this pink point here, comparing the improper inequality, you have to explain this or kind of write it out like this. The most important part, I think, of all of this is kind of like this right here, showing that f is under u, but then you still really need to link it to this infinity because this is the only thing you really need to know. You really do know because of it's given to you. So then if you take this 1675 and you add it to the absolute maximum that can be is 315, you get this 1990, which is of course less than 2000. So how do you get these last few points? Well, that's the challenging part of these two. You need to have some sort of inequality comparison, or if you use words, you could, but man, it's so much easier to compare this with just, integral ideas like this. And then the explanation, you need to kind of summarize all this and say, hey, I knew that this guy here, right here, was 1675, and I knew that this guy at the absolute maximum, according to all this stuff, is going to be 315. So then this answer is right there, and this answer is right there, and then that total has to be under 2000. Good luck for that one. It's a challenging problem. And if I was in class with you right now, I would have sprung this question on you cold in class to simulate anxiety and frustration. I can't do that right now. But the purpose of doing that is to try to get you to stay calm through the AP test, to relax, and to be able to power through, even if you don't know exactly where to go. Your mission is to get every single point you can. All right, and then D, this is not a testable item on the 2020 exam, but it's still a really good question. It's something we should practice. Now it completely changes gears and talks about a boat moving on the surface of the water. Nothing else above this plankton stuff is relevant. At time t greater than 0, the position of the boat is this parametric or vector equation. X of t, x prime of t is this, y prime of t is this, t is measured in hours, these are measured in meters, find the total distance. Hopefully you remember your total distance formula, which should be memorized, but for the 2020 exam, since it's parametric vector, it's not going to be on there, but it's just a simple integral problem. So the integral of dx to t squared plus dy to t squared and square root of it. This was probably one of the easier parts of the problem if you remembered your total distance or your arc length formula. And then obviously your integrand is this piece right here. We got 1 point for that. And then your total distance is going to be typing that into the calculator. One more time, it's a good problem, even though it's really hard. You have to figure out how you're going to make sense of a problem like this. Good luck, everybody. Keep powering through. Do the best that you can. You'll be fine.